Text embeddings are an important step in the field of natural language processing. Natural language processing is a subset of artificial intelligence and machine learning, where we deal with unstructured human language data in the form of text. If you'd like to understand more about where natural language processing fits in the bigger area of machine learning, I'd like to suggest my course Applied ML The Big Picture. But now that you've decided you want to learn about natural language processing and specifically an important step called text embedding, let's get into it. Text encoding or text embedding are the set of techniques that are used to convert text into its numerical representation. And why do we need this numerical representation? It's because any computer algorithm, including machine learning models, can only work with numerical data because that's what the computer can process. And while we convert this text into its numerical representation, we have to be careful about capturing the essence or the rich information the text has to offer. For example, a single word can have different meanings based on the context it's used in. Let's take the word run. Run has different meanings in the sentence running a test versus running a race. In another example, just based on the literature we read, the news we're exposed to, just the world we're exposed to, we know that Tokyo is to Japan just as Madrid is to Spain. But how do we teach that to the machine? Similarly, how do we teach etymologies? That is, common root words. How do we teach derivatives of the same word? Walk, walking, walked. How do we teach gender nuances, man versus woman, king versus queen? There's just so much that needs to be captured from human language. It can even include sentiments, it could include relationships between entities, such as the Tokyo and Japan example. And we have to choose an encoding or embedding technique really based on what our natural language processing use case needs. And this encoding or embedding can either be a single number in some forms of encoding. It can be several columns of single numbers in the form of one hot encoding, or it can be a vector of numbers called vectorization, which happens with a lot of embedding techniques. So how do you choose between encoding and embedding techniques? It depends on what information from the text you need to be represented in its numerical format. But then you can also make a choice depending on the size of your vocabulary. If you have very limited vocabulary, you could use one-hot encoding, label encoding, and ordinal encoding. Let me give an example for one-hot encoding. Let's say you have a vocabulary of only 3 unique words. The 3 unique words are orange, banana, and apple. Let's say your first sentence is orange only. Then your encoding would have 3 columns with values 1, 0, 0, meaning orange is present but banana and apple are absent. If the second sentence or the second word is banana only, then you have 0, 1, 0, meaning orange is absent, banana is present, apple is absent. And for apple, it would be 0, 0, 1. Label encoding can be used when you don't really have a specific order to be followed between the various items or the various unique words in your vocabulary. And ordinal encoding is used when there is a specific order. For example, let's say you have a text column on t-shirt sizes. The t-shirt sizes actually have an ordering between them, like small is less than medium is less than large. So these are some of the encoding techniques that you can use when you have very limited vocabulary to work with. But when you go from medium to vast vocabulary, then we go for vectorization techniques and embedding techniques. And in this course, what we'll be working with Learn to Build is specifically embedding. And that's because in real world, vocabulary is much more than just a handful of words. And we also have a lot more context and rich information and nuances to capture from the human language text, such as synonymous words, opposite words, entities that are linked together. We have to learn different meanings of the same word based on the context it occurs in. We have to learn roots of words, etymology, and we might have to learn sentiments, semantics, and so on. And if you look at the applications that all of these learnings will help us, it could be similarity finding applications. It could be finding differences between two sentences. It could be ranking sentences, for example, just ranking web search results based on your search query. In those cases, encoding doesn't do us much help because there is a lot of information to be captured from human language text than just indicating the presence or absence of a word, or just ordering words, or just assigning a random number or sequence of numbers to a word. So that's why we focus on embedding techniques and learn how to build them, because it's a very useful pre-processing step or an entire research area by itself in the field of natural language processing. In addition to some of the most common embedding algorithms, we'll also go over TF-IDF vectorizer, which is based on frequency or counts of words and can also be used to produce dense vectors.